Do you know what is the safest phone to buy, the safest laptop to buy? How do you base your decision when you go to a shop to buy your next gadget or your next working device? Which devices do you think they have the strongest and the safest features, and how do you base that decision? Most of us, we base the decision based on the branding and marketing. You watch YouTube videos, you watch the TV ads, and you buy a product, Samsung, Huawei, iPhone, based on what they tell you. How you should decide? You should decide on the types of algorithms that they use to protect your privacy. You should decide based on their track record, the reputation that they have on implementing those algorithms, and you should base your decision on the regulations that they have to be compliant with. Because if you have a company A that operates in a country B with no regulations whatsoever, and you're buying a product from that country, well, maybe they can say whatever they want in their YouTube videos because there's no regulation in that country to penalize them for making false promises. Now, in this video, I'm gonna show you the algorithms. I'm gonna explain which algorithms you should be looking, and I'm gonna tell you which companies are using those algorithms. So I'm gonna tell you the actual names of the companies that have the safest track record of implementing these algorithms. But before I tell you, I don't want you to think that this is marketing for some company in China or for some company in the US. I'm actually going to present this in a lecture. I'm a postdoctoral researcher in the University of Oxford. I work for the Department of Computer Science. So I'm not doing this for a company, I'm doing this for a lecture. And before I go there, I'm testing my lecture notes by doing a short video, which I'm going to include as a promo material. That's all that there is to it. So my purpose of this is purely educational, not to convince you to buy a specific product. How did I build this lecture? Based on the publicly available information on which device is using which algorithms. So I'm going to start first with a whiteboard, and then I'm going to go to a browser. Why is the topic of privacy important in our society today? Because the new regulations in the European Union and in the US require, and many other countries in the world, UK and various other countries, require that the algorithms are based on transparency and accountability. So those are the two key areas that we're looking before we start using a product. Now I'm going to show you in the next slides, I'm going to show you a specific algorithms that they ensure your ownership of the data and the responsibility, and that is based on the data disclosure and on the compliance with the ethical laws. I'm not going to dwell too much on this topic because the purpose of today is to show you the actual algorithms, not the reason why they're important. One specific algorithm that we're going to be talking about today is differential privacy. This is an approach which I will give you more easier examples to digest, but these are my PowerPoint slides that I'm going to be teaching on the course today. So I'm not going to be going through these slides in very much detail. I just wanted to show you that there is a process of how this differential privacy works. Is that you collect data, you analyze data, you determine a privacy budget, then you apply a noise. This is the key section, that you apply a noise according to the budget that you have, and then you can call that process completed. In the actual lecture that I'm going to be delivering today, I'm going to be using different examples for this. So I'm going to be using examples from data that I have collected. So that is the original data, and this is the data with added noise. And you can see that some of the things are different. So that, for example, is completely different than on the data set with noise. And this outlier here, it's not showing in this data set. So the more data noise that you add, the accuracy decreases. So you need to look at this graph, that the noise is always dependent on the budget that you have, and by budget I mean how accurate do you want the final results to be. Now this is another slide that I'm going to be using in my lecture notes today, but again I won't be going through this. I have a different example for you, a lot easier to digest. But this is again how differential privacy works. Differential privacy, it's one of the leading approaches for protecting your privacy and collecting the data that would enable organizations to improve their products. But usually it starts by collecting data, and if you think that companies are not allowed to collect data, get over yourself. Companies will collect your data, otherwise they can't operate the system. The only way that they would not collect data is if you don't use that system. If you use the system, everything that you type on your computer is read. Just to be clear about that, everything that you type in a browser is stored. Everything that you type on your device, it's analyzed. But you need to have a privacy model for that, and then you need to determine how much noise you add in order to protect the user from other people understanding what is he typing and what is he doing. And that then you need to analyze the data, perform tests, and you can, at the end, you can even release the results after using differential privacy, which I will show you examples of how anonymization, for example, doesn't work, why differential privacy is required. And this is the final slide that I'm going to have on this topic in my presentation later on today. It actually starts in half an hour. I'm just testing my recording equipment because part of it is going to be virtually, so that's why I'm doing this. Differential privacy is a method that ensures that individual data privacy in large data sets. In small data sets, it doesn't really work because it's going to add noise and it's going to mess up the data set. So you're not going to get the accurate results from the analysis. So it only works in large data sets. If you have a small data set, don't look at differential privacy. It's not going to be applicable to you. In terms of data analytics context, you need to collect and use data for analysis with privacy consideration. And that is one of the key criteria. If that is something that you have to do, then the differential privacy is one of the methods that you need to start looking into it. What are the mechanics of differential privacy? It adds noise to the data to mask the individual contribution. So when you add noise, it makes it easier for to hide your individual contribution to the data set, so to speak. So if you said my age is X, my height is Y, you want that to be hidden. Then you need to have a privacy budget. What does it mean to have a privacy budget? Privacy budget is simply, why is this thing doing that crazy stuff now? Hold on, let me click something and see. It's disappearing. So I did some function on the pen, which I don't know how to undo. And actually, this is one of the reasons why I'm doing this testings before the actual session, because yeah, it's gone. It's disappearing. So I'm gonna have to restart this and find my slide again. Okay, there we are. Let's see if that now is gonna work. Okay, now it stays. The privacy budget means that if, let's say, you're collecting data for voting, for election, you can't add too much noise to that data because you're going to be confusing the election results. And you need to consider the benefits and the limitations from balancing data utility. By the way, if somebody knows what did I click on this thing that it was disappearing, it was some function that I used on the whiteboard. This is the Apple Free Flow software. If you're using Apple Free Flow software and you know what I did, please send me a message below so I won't do it again, because if this happens during my lecture, they won't like it. This is the lecture notes that I will be presenting in a much longer version today. Now, for this session, I have an explanation that is going to see that differently. First, what is differential privacy? Well, differential privacy is that companies, they want your personal data to improve their products. That's what they want, your data. And I apologize about the background noise. That's students slamming doors. They want data. They want your data so they can improve their own product. But you want to protect your data because you don't want people to know what are you doing, what are you up to, what's your weight, what's your height, who are you dating, how many children do you have, what's the names of your children, what's your medical record. You don't want to share that. But the companies, they want. your data in order to improve their product. So if you use differential privacy, you both win. So your personal data as an individual will be protected, and the company will be getting the data via the differential privacy, and then they're gonna make a better product. So let's say better iPhone. Well, I don't know why am I using iPhone. I shouldn't be using names. The key here is that you need to trust that your company, so company X, well, X is a name now. Oh my God, I can't. So company, this is a company, organization. You need to trust as an individual, you need to trust that this company is going to protect your data. Otherwise, you're not going to be using that. You're not going to feel safe using that product, that company. And usually they say that we anonymized your data. We didn't put your name. There's no name. There's no personal details here. There's no email, yada, yada, yada. Okay, how strong is that anonymization? Is that anonymization strong enough for people like me, let's say computer scientists? How strong is that anonymization for computer scientists not to be able to put your name back on the data set, to say, okay, this is the guy, I know that's the guy. How strong is the anonymization? Let me give you examples of how it's not very strong. Here we're going to use an example from Netflix. Is this how you spell Netflix? I don't know. But Netflix had a competition when they asked many competing teams to determine an algorithm that can predict user behavior. So they wanted to know what kind of movie are you going to watch and how many stars are you going to rank a movie. And then they would push that movie to you that you're going to rank 5 stars. They won't push the movies that you're going to rank with 2 stars or 1 star. That was the goal. That was the reason why Netflix had this competition. And to help with the competing teams that they were building the algorithms that could achieve this, they provided a data set. And this was a fairly large data set. And they said it was anonymized. And how did they anonymize it? Well, the names, so the names of the users were deleted. They added also a randomness to the score, to the stars that they provided. So if maybe they would replace some stars with 1 star, because they didn't really want to learn from one user specifically. They wanted to learn the overall users, how do they perform. And in that case, in this kind of very large data sets, one individual is not important. In terms of data analytics, is not important. And how many this data set, how many personal data sets contained from individuals? It had around 480,000 users in this data set. So that data set was collected from around 480,000 users. And in that ranking system, they included around 100 million ranking. So 100 million ranking from 480,000. Let me write that, 480,000 users. This was from 17,000 movies. And that was the data set that they provided to this competition on finding an algorithm that is going to help them determine the scoring, how many stars you're going to score. And this is, again, you can see what they're doing here. In some of the other videos, I was talking about recommender systems. So they were trying to build a recommender system. Recommender systems are supervised algorithms for determining user behavior, so they would attract more users. But this anonymization didn't really work, because just by removing the username and replacing some of the scoring system, that was not enough. And 2 computer scientists from the US, from Texas, they analyzed this data set back in 2008. So we can talk about it. This is not really a big deal for Netflix now. And what happened is that these computer scientists from Texas, they analyzed the data set from Netflix, and they compared that with a data set from IBM. IMBD. It's not IBM. IBMD. That's another company that stores those datasets. And they managed to link those datasets and to identify the users. And this is called a linkage attack. And we know that this happened because those guys from Texas, the two computer scientists, they actually published a paper on this. And everything was explained in the paper, how they did it and how other people can replicate that. But let's say that example maybe is not really that interesting for you. Let me show you a different example. And this is going to be about the governor of Massachusetts. This is his name was William Weld. And again, this was in the 1990s. So nobody really cares about this now. That's why I'm using old examples. I want to explain how anonymization is not a very strong thing, as it's not as strong as people might come to believe. What happened with this governor of Massachusetts? Well, the hospital in Massachusetts decided to release the hospital visits of state employees, and they anonymized this by removing names, addresses, and and many other things. So they eliminated many of the fields that could associate individuals like William, the governor of Massachusetts. But it was not enough, because just by anonymizing the names, and the other data, this was a specific data set that to hospital visits of state employees. And you see that made the data set very easy to narrow. And two computer scientists, well, actually it was one computer scientist, and she was a woman, so I shouldn't really be saying two computer scientists, it was just one. She was a lady. And she showed how easy it is to reverse this. So she took the public medical records, and then she took the voter registration. So this is the voter records and the medical dataset from the hospital in Massachusetts. And when the medical record was combined with the voter registration records, then it was very easy to narrow the people, because this medical record here, medical database, was specific to the state employees visiting the hospitals. And when combined with the voter records, this computer scientist was able to, just by using the gender and the zip code and the date of birth and similar things like that, which this record should have never contained date of birth. But Americans are sometimes a little bit oblivious to these things. So the governor was exposed, because when they had, let's say, a very large data set. So that was a very large data set. When they combined it with this, in the area of the zip code where this governor was staying, since this was the only data set of the medical records of the state employees, there was, in this combination of those two, there was only one person in that area with a medical record. So the governor, William Weld, had a zip code, and in that area there was only one person. They knew that is him. And then they were able to expose his medical records. So you can see how that is problematic, how some people might get extremely upset about that. And they didn't really understand that this combination, this linkage attack, can be performed so easily. And now, how is differential privacy going to help us resolve this? So how is differential privacy better than anonymization? Well, let's look at an example here. So the first example, and you can think about many question and answers that are with two boxes, yes or no. So yes or no. I'm trying to think of an example that would compromise you, that would create a significant damage to you. Let's say we all work from home now. How many of us are having sex during work hours from home? Yes or no? What is the answer? But that's a very controversial. I think it's a little bit pushing it too much. Usually this is used differential privacy, this kind of yes or no, are used for topics like drug and substance abuse. If somebody is using substances and they don't want to talk about it, they don't want the world to know about it because they might lose their job, then you would use differential privacy. But there's still yes or no. And as we have seen with the last two examples, anonymization, it's not sufficient for protecting the identity of this participant in that study. So how would this work in a different scenario, for example? So how would data the data privacy help us protect that? Well, first, when we are applying differential privacy, what happens is that it's never really simple yes or no as it's seen here. So that is the answer that we collect in the study. But when that is sent to the server, the server is going to do something different. So it's going to be, okay, if it's yes or no, well it's going to be 50% chance that is yes, it's going to be 50% chance that is no. Okay, that is the data that the server is getting. This is the result. And then if it's yes, then okay, maybe it will just continue as yes. If it's no, then there's a kind of like a flipping coin thing that happens. And in this one, it could be another decision, yes or no. So this is, let me try to find a way how to explain this because it might not make sense. I had a note here, which I can't find it. But let's say this is something about drug user who is using drugs and he doesn't want his employer to know. This is not the same like voting election because you don't need to find out the precise number of votes. Is it 1 million? The US has like 300 million. Let's say it's 300 million and one in election. That one vote counts. But in drug substance abuse, you just want to know the percentage of people. And if you randomize 1 or 2 people, that's not going to affect the overall score, but it's going to give you a plausible deniability. So this employee here, his name could be John or Jane or Jim. That person will say, well, how do you know it's me? It's using differential privacy. So that was like a flipping coin. So when that was sent to the server, it could have been yes or no, but then the algorithm did a flipping coin and it chose this answer, not my correct answer. And that answer then went to a second flipping coin, and that was again yes or no. Because this would only be a small percentage of the data, it's not going to affect the overall. But since that is going to be picked at random, so here or that at that data point, it's not going to affect in statistics and probability. That doesn't make a difference. These small numbers, they're not going to change the actual overall. If you don't know what I mean, you really need to refresh statistics because that's going to be too long to explain. You're just going to have to take my word for it. Small changes in a large data set with 300 million, and if you change, I don't know, 3,000, that's not going to affect, but it's going to give you a plausible deniability that you can say, no, differential privacy was used. So Jenny here can say that was not me at all. You're confusing things. So that is how one simple explanation of differential privacy and what's interesting use case. What's more interesting in this about the governor, specifically the example that I gave you, how that female computer scientist in the 1990s found the governor and his medical record. She also said that around 87% of all the Americans, all the people living in the US, can be found and their data can be traced based on 3 things. One is gender. So if this computer scientist knew that your gender, then and the other 2 things, she will know who you are. So first is gender, second is the zip code, and third is the date of birth. And this means that 87% of the Americans can be traced with those. And if you live in a country like developed country like the US, UK, this makes perfect sense to you. What do you do when you go to visit your GP? They're not asking you, quite often they're asking you for your date of birth. And since your date of birth is so unique, sometimes they say, is your name Jane? You say, yes, my name is Jane. Just by your date of birth is enough to find you. But if you combine that with a zip code and your gender, it's I would say the statistical probability is probably higher, but I trust that that's female scientist knew what she was talking about, because there's other things that in that study that maybe I didn't understand, that it's only 87% of the US population that could be identified. But if 87% seems to you like a small number, I would say if I run that, I would be willing to bet that my number would be higher, given that this was done in the 1990s and now we are in 2024. So the things have changed between then. And I think that's the main reason why I think that number has gone up. Now, since 87% of the US citizens can be detected with those three different pieces of information, you can see that your identity is not very well protected. And then the question becomes how these technologies can be applied to protect your privacy. And then differential privacy, for example, prevents those linkage attacks. And it gives you plausible deniability. But when we apply differential privacy, we don't really use the example that I showed you with the drug addict and the tossing of coins. We apply something that is called Laplace distribution. With that Laplace distribution, we can have far more safer, far easier. The distribution goes over larger data sets. And then, having explained why anonymization is weak, why differential privacy is stronger, having explained the examples that differential privacy is not going to work in every scenario. In voting, it's going to be difficult because every voter counts. In medical studies, since you're looking at the percentage, it might actually work. Now, with that in mind, question is, which companies are using anonymization and which companies are using differential privacy? Because not all companies are using differential privacy. I'm going to tell you two companies that they are using differential privacy, that you can actually check their differential privacy approach. But before I tell you that, let me just say that anonymization is a perfectly okay system. It works fine. It's cheaper, and that's why many companies prefer to use anonymization. But given all the examples that I've given you, you can see how a company can relate, and with a linkage attack, relate your personal information with who you are. And when is this becoming a problem? It's becoming a problem because your iPhone, which we all use now, can store everything that you type. Everything that you type is seen by that device. And the company, the organization here, has access to everything that you typed, every web page that you have seen. So every browser that you visit, all of that information is going to the company. We know that. That's not a secret. It's not a conspiracy. The companies have that data. The question is here, which companies do you trust that they are not going to send that data to be abused? Which companies do you trust that they have the technological capability to protect your identity? And now, in terms of differential privacy, the two companies that are using differential privacy and specifically for those kind of things, the things that you type, the things that you browse, to store those are, and many of you won't like this, but it's Apple and Google. Those two organizations are using differential privacy. Why are they using differential privacy? What's the purpose? Because they're not using differential privacy for everything. Nobody's using differential privacy for everything. Question is, for what data are they using differential privacy? The Apple has been using differential privacy since macOS Sierra. Okay, I'm not going to be typing this. It's going to take too long. I need to go to my lecture. I'm running late, actually. Apple has been using differential privacy since iOS 10, so macOS Sierra, and they're using that for websites. All the websites that you visit are stored with a differential privacy. What images are used in specific contents, so they're hunting for people that they might be, I don't know, pedophiles or I don't know. But also what words did you type? And if this wasn't clear enough so far, every company is able to do that. Every device is able to do that. So it's not about Apple doing it or Google doing it. Every single device has the capability to understand the words that you are typing and the websites that you're visiting. But only Apple and Google are using differential privacy. Most other companies are using anonymization because it's cheaper, it's faster. They don't have to pay too much money, they don't have the technological knowledge. Now, Apple is using this differential privacy for websites, for images, for words. And then they want to add, let's say if there's a word that is missing in their database in the keeper, they want to add that. So they use it to improve their services. With Apple, the use of this differential privacy is documented, but it's not open source. So they have documented that process, but you won't be able to see it. With Google, it's not only documented, but it's also open source. So you would be able to go to their sources and see how are they using differential privacy. They have a library specifically for that. And what is Google using differential privacy for? It's using for the use of Chrome, and they're trying to detect how data on malware that is affecting their browser. So they want to improve their browser for security reasons, basically. Second, they use it for maps. And we know this because Google Maps is using your data to improve their performance on live tracking. And that is using differential privacy, which means that you have plausible deniability about anything that is stored on Apple and Google. And those are the most secure organizations, which most of you would contradict and argue. But I would challenge you to look at the algorithms and look at the regulations that they have to comply and not think about personal opinions or videos that you have seen on YouTube. Please don't think in terms of branding. Branding is designed to brainwash you so you belong to a clan. You belong to a company that is producing a specific device. They want your money. So you should be basing your decision based on the algorithms that organization is using, based on their competences to implement those algorithms, and based on the regulations that they have to comply in which country. So if this company A has been shown to be fully compliant in the European Union and in the US, means that they are compliant in the European Union with the GDPR and with the AI Act, and in the US that they are compliant with NIST. So there are specific standards that companies have to be compliant, specific regulations. Otherwise, they pay very hefty fines. So the GDPR would ask for like 4% of your total profit. And for large companies, that is a lot of money. When is differential privacy working and when is it not working? Differential privacy is working in large data sets. So this is a big data, because when you can add specific things, you don't really care about small minor deviations. You're looking at statistical probability, the percentages. It doesn't work in small data sets because that noise that you're going to add will mess up the data set, and the data set will start producing wrong results. And then the question here is, do you use differential privacy or not? And differential privacy adds complexity, adds very specific, requires very specific skill set to implement it, but it's stronger than anonymization. So the question is, can you anonymize something sufficiently for people to feel protected? And in companies, they need to acquire data to learn about how to improve their products, but you also need that company to be able to protect your privacy. So how do you base your decision in the future of how do you buy a product? Look at the algorithms, look at their competences. Do they have a track record of implementing that in the past? Look at the regulations that they are compliant with. I have to end this because my lecture starts in 5 minutes.